So I need to take the derivative of this function. And I can see that I have a product here. So I'm going to use a product rule, uv plus uv, move my prime sign from the u to the v. And as I do this, I think I'm going to have to use the chain rule also. So y prime is equal to, well, u prime, which is x cubed, 3x squared times v, 2x minus 5 to the fourth, plus u, which is, let's put a little bracket here just so we know, x cubed times v prime. Well, v is a composite here. It's a function and a function. So I'm going to go outside, inside. So this is going to be 4 times my inside, 2x minus 5 cubed, times the derivative of my inside, which is simply 2. So just notice here that in this section right here, I just used the power rule on that. So let's use some algebra to try and simplify this a little bit. Y prime equals 3x squared, 2x minus 5 to the fourth, plus I'm going to kind of move my constants to the front. I have a 2 times a 4, so that's going to be an 8. So I have an 8x cubed, 2x minus 5 cubed. And now to further simplify this, I have to see that in this binomial, that plus that, I have some common terms. I have x squared as a common term, so I'll take out an x squared. And 2x minus 5 cubed is a common term. So I can take out an x squared times a 2x minus 5 cubed. And then I'm left with, in this part right here, I pulled out the x squared and the 2x minus 5 cubed. I'm left with 3 times 2x minus 5 to the first, plus, well, I pulled out an x squared, so I'm left with an 8x, because I pulled out this 2x minus 5 cubed. Pause it and take a look at that and make sure you see what I did. So I can see a little bit of additional simplification. Y prime is equal to x squared times 2x minus 5 cubed times, well, 3 times 2x is 6x minus 15 plus 8x. Y prime is equal to x squared, 2x minus 5 cubed, 14x minus 15. Now sometimes you're going to be working problems and you're not going to see, you're going to come up maybe to like this part right here and think that you're done or that you're stuck. But, you know, if you go into the book and you see the book gives you a different answer like this, see if you can move from this to that. And that'll help you kind of develop and work your algebra skills. Now, the other thing I want to do is I want to check my answer here. So I'm going to check it using graphs. So I'm going to get my calculator up. And the first thing that I'm going to do is I'm going to enter in my initial equation, my very first equation. And then so I could graph that. I could go zoom 6, and it'll graph that, I hope. Yeah, it looks kind of weird. A little tight. I probably should spread it out a little. I think I'll spread it out a little bit here. I'm going to make my my x minimum -5 and my x maximum 5. That should spread it out a little bit, see what it looks like now. Yeah, a little bit better. You know, we can see it a little bit better. I can see it turns around up at the top someplace. I played around with my window a little bit offline. That's the window I ended up with, so I could kind of see more of the graph and have it look pretty decent. But now what I'm going to do is I'm going to graph the derivative of my y1 function. So the graph I want to do, I'm going to go alpha f2, and I'm going to select n derivative, that's 3. And I want it to graph. So I want to graph, first I put in the function, and instead of writing the whole function all over again, I'm going to go alpha f4, and I'm going to enter y1. Because y1, as you can see right there, I'll try and make you be able to see it right up here, that's the function. So I'm graphing the derivative of y1, I'm doing it with respect to x, and instead of at a particular value, I want to do it at all x values. So y1, x, x, and I close my parentheses, and now I hit graph again, and hopefully I'm going to get a derivative graph here. Oh, that's a very odd-looking derivative graph. Well, we'll try it out. We'll see if that is a derivative graph. So what I'm going to do is I'm going to go back to my y1, and I am going to hide the graph of my function. And I highlight the equal sign, I press enter, and it makes a longer equal sign. So now when I press graph, the first one is hidden, excuse me, and the only one that is showing is the graph of my derivative. So I can't see the whole graph of my derivative there, but I want to see if that really is the graph of my derivative. So I'm going to go, or if I actually, what I want to do is I want to see is if this is in fact the equation for the derivative. So I'm going to enter that into my calculator. So offline, I just entered that equation, this one right here, I put this equation here into my calculator, and when I press graph, those two graphs should be overlapping. I shouldn't see any additional graphs, so let's give it a shot. So I'm going to press graph, and I see my first one there. It's still functioning, and what do my two graphs overlap. Now I think I'm going to try that on Desmos where I can see them a little bit better. But even if I didn't have Desmos, I would feel pretty comfortable that both of those graphs which we're graphing are completely overlapping one another. So you can see here that I entered in the original equation, and I entered it in as f of x equals, because I'm going to want to make a derivative out of this. And I'm just going to look at the graph a little bit better. No, that's good enough. I can kind of see where it goes. So if I want to find the derivative, Desmos is really nice. I go here to Functions, Miscellaneous, and I just want to find the graph of the derivative, and I want the derivative of f of x. So it just gave me the derivative of f of x there in blue. And I'm going to check that with the equation that I came up with the derivative. So just type that in. I think I'll blank out my original, and I can see that I have this green one, which is the equation that I wrote in, and it looks like it's completely covering the blue one, but let's find out. Let's remove the green one. And you can see that it is exactly covering the blue one. So I'm very comfortable now that the equation I came up with for the derivative, comparing it with the graph, that it is in fact my derivative.